Good morning and welcome to class today. I trust you're well rested and ready to learn. Today we are going to be learning factorization of algebraic expressions. In this class, we are going to understand what algebraic expressions mean. We are going to understand what factorization means. We are going to learn steps to factorizing simple expressions, and we are going to learn factorization by grouping. So, what is an algebraic expression? An algebraic expression is simply any expression that is built from variables and possibly constants and coefficients. Let us look at this example. We have 2x minus 4. This is an algebraic expression. In this expression, we have 4 as a constant. As you well know, 4 is a number and its value is fixed. That's what makes it a constant because it doesn't change. X has an unknown value. So the value of x can be 2, it can be 9, it can be 0, it can be a negative number such as minus 5, it can be a fraction such as half. The value is unknown. That is why it is called a variable. Whatever number multiplies the variable is called a coefficient, or the coefficient of that variable. Now, before we go further, I would like you to understand that algebraic expressions are different from algebraic equations. An equation has the equal to sign in it, while an expression doesn't. So this is an expression. However, if I equate this to 0, it becomes an equation. Now, not every algebraic expression must have a constant or a coefficient. However, all of them must have variables. Without a variable, it is not an algebraic expression. So now that we understand what algebraic expressions mean, what is factorization? Factorization is the method of reducing algebraic expressions into products of irreducible polynomials, such as monomials, binomials, and trinomials, and so on. A monomial is simply an algebraic equation with a single term. For example, 3x. That's a monomial. A binomial has two terms added together by either plus or minus. We have x plus 2 or x plus y, a plus b. That will be a binomial. A trinomial has three terms put together with our addition or subtraction signs, such as x plus y minus 5. This is an example of a trinomial. But going back to what factorization means, factorization simply means separating an expression into such a form that is the product of two or more binomials, trinomials, or monomials. Looking at this, for example, we have 2x minus 4. We can break 2x into 2 times x because those are the product of its prime factors, while x can be broken into 2 times 2. Looking at these two brackets, we can see that 2 is common to both of them. If we factor out that 2, we'll be left with x minus 2. So the factorized or simplified version of this expression is going to be 2 into bracket x minus 2. Let us check to see if these are equal. Let's take x to be equal to 3. Putting that into this expression, we have 2 times 3, which will give us 6 minus 4, and that's going to give us 2. In this expression, bracket open first before multiplication. So 3 minus 2 will give us 1. 1 times 2 will give us 2. What if x is equal to 7? 2 times 7 will give us 14. 14 minus 4 will give us 10. How about this? 7 minus 2 will give us 5. 5 times 2 will give us 10. So no matter which value you take for x, both of these expressions will give you the exact same value. So they are equal. And yet this is a product of two polynomials. We have 2 being a monomial and x minus 2 being a binomial. So this is a simplified version of this. And factorization is simply the process in which we can reduce an expression like this into an expression like this. Now, for factorization by grouping, what if we have an expression of this form? ax plus ay plus bx plus by. Looking at this in general, we immediately realize that there is no common factor. We have a common in the first and second term, but it is not present in the third and fourth term. We have x common in the first and third term, but not present in the second and fourth term. We have y present in the third and fourth term, but not present in the first and third term. And we have b present in the third and fourth term, but absent in the first and second term. So how do we factorize an expression like this? The first step to factorizing this expression will be to separate it or to arrange it. This is already arranged, but assuming it's not arranged in such a way that we have two factors together and two factors together, it will be best to arrange it in that form before we begin. When we have our factors a in the first two terms and b in the second two terms, since if we want to do it this way, then we can group them and factorize separately. What do I mean by grouping? Separate the first two with a bracket and the second two with a bracket, depending on the type of expressions you have. After separating them in this form, we can now see that a is a common factor here and b is a common factor here. It becomes a simple thing to factorize a out of this expression and factorize b out of this expression. Doing that is going to give us a into bracket x plus y plus b into bracket x plus y. We can now see that x plus y is now a common factor between this and this. So factoring out x plus y, we are going to have a plus b into bracket x plus y. This method of factorization is known as factorization by grouping. This is a very important step to learn because it is the key to learning factorization of algebraic expressions, which is also key to learning solving of algebraic equations by factorization. I hope you have been able to learn something today. Here are some examples some exercises that you have to factorize. Remember, if you try to factorize it and it's not possible, then try rearranging the terms. It's possible that it's not well arranged and that's why you're not able to factorize. Here are some practical exercises. I expect you to solve them and upload your answers in Google Classroom. I'll be grading you. Thank you and see you later.